This is part 2 of the What the Physics video on vectors. Here we're going to be focusing on the analytical method.
On to some of the trig type stuff. Okay? Guess what I need? Volunteer. Volunteer! Oh! Yes. Volunteer? Volunteer, thank you, dear. Come on up. Okay, so what you need to do, okay, so we see this is called the analytical method. You learn about these trig functions in geometry. Okay? When I say trig, you say, there, I'm not in trig yet. It's okay. We're just doing basic sine, cosine, tangent functions. Okay? When you get into trig and you take the secant squared of the something or another, that's not this. Okay? This is just SOHCAHTOA stuff, right? So, in math class, you learn that sine of theta is blank over blank. So what do we say in math class? All right, so in that, yeah, just grab one and drag it over. Yeah, it's infinite repeats. Opposite over hypotenuse. Excellent. Okay. Cosine is adjacent over hypotenuse. Lovely. And tan theta is right. All right. Okay, now, in physics, I mean, it's not wrong to say opposite and hypotenuse and adjacent and such, but in physics, we're typically going to be using reference angle from the x-axis. So typically, we just need to say, hey, the opposite is going to be the y-axis, and the adjacent is going to be the x. And instead of saying hypotenuse, we're going to say r for resultant. Okay? So, go ahead and redo it in terms of physics, please. Okay? People are checking this. This is legitimate, right? Right. Okay. Good. Thank you very much. Yeah. Okay. So, we're referencing stuff, new stuff from math, but it's all just review, right? Sure. Let's add some vectors that are perpendicular. Say, there, we've already done that. Well, we're going to do these not so much graphically, but a method called analytically. Analytically means we're using calculators. That's pretty much what it means. So if I walk 3 meters east and 2 meters north, what is my displacement going to be? You say, well, how would I do that? Well, first of all, I would draw a sketch of a triangle to explain what I'm doing. So I'm saying I'm walking 3 meters east and 2 meters north, yeah? So there's my sketch. Hold this so we can kind of see, okay? So it's like I'm going there, and then my resultant, my hypotenuse, right? But it's helpful to visualize what's going on. The next thing I'm going to do is break these guys up into the x and y pieces. So I have 3 meters east. Well, I can't plug east into my calculator. If I say north, south, east, and west, yeah? That's effectively the same thing as saying 0, 90, 180, 270, and then 360 if you like. Okay, but the point is, if I'm saying east, pretty much just means 0 degrees. North, 90, so on. Okay? So, 3 meters at 0 degrees. That's on the x-axis, right? Would that be a positive direction or negative direction? Positive. So that would be a +3 on the x-axis. Any y aspect to it at all? No. So what I've got here is 3 for the x and 0 for the y. Then I'd say, okay, 2 meters at 90 degrees. Well, 90 degrees, that's on the y-axis. So that'd be like saying, what's my y component? Positive 2. What's my x component going to be? 0. So there I go. If I had more vectors, I could just keep adding those on as well. And we'll do examples of that but later. My big values here, my big X and my big Y. Well, I'm going to add up all my little X's and get my big X. This one's easy to do. I'm hoping people realize that. What's 3 plus 0? What's 0 plus 2? 2. Awesome. There's my big X and my big Y. Okay? And I've got my sketch up here, and so hopefully it's making sense. This was the 3, this was the 2, and then I'm going to be looking for this result here, yeah? Okay? And yeah, they will get more complicated than this, just so you're aware. How would we combine these two guys together? With the Pythagorean theorem, right, okay. A squared plus b squared equals c squared, right? Yeah, I guess, but in physics, we're talking x, y, and r, right? So x squared plus y squared equals r squared. Same thing. Do the math, please. Again? Okay, oh, square root, okay, sorry. Square root of third. In math, they love square roots and fractions and stuff like that. In physics, we like decimals. So, go. Yes. Okay. 3 point, I just put it as 2 digits. Really, I only gave you 1 digit in the first place, but that's kind of silly for a decimal in this case. 3.6 would be plenty, okay? Oh, and by the way, meters, right? Because I did give you meters in the first place. Now what about for the angle? People are like, oh, I got this one, man. Northeast, right? Northeast implies exactly northeast, as in 45 degrees northeast. Is this 45 degrees northeast? No. So we can't just say just plain northeast. What we got to do, give a little more detail. How would we get that angle? We've got a triangle. Okay. I've got my y, I've got my x, and now I've got my r. That's fantastic. But now I want this angle theta. What trig function would deal with the x and the y, or the opposite and the adjacent? Tangent, right. So tan theta and we knew this from the previous slide, right? Tan theta is y over x. But I don't want tan theta. I want just plain theta. So you say, oh, that's fine. We'll divide through by tangent. You cannot divide through by tangent. Tangent is a function. It's like, how do you get rid of a square root? Oh, divide through by square root. No, there's no such thing. Okay? In order to get rid of a square root, you would square something, yeah? You do the reverse function. What's the reverse function of tangent? Arctangent is or in your calculators, it's second tangent. Okay? That's fine. Okay, so in our calculators, we press second tan y divided by x. This means our calculators need to be in a particular mood in order for this to work, right? Degrees. As far as we're concerned in this class, folks, we will not be using radians. Radians are stupid. Yeah, if you're in algebra 2, you don't even have to worry about switching back and forth. Okay, if you're in geometry, you don't have to worry about switching back and forth. If you're in trig, they'll probably want them in radians. What a pain. The degrees versus radians thing only matters when we're doing the trig stuff, though. It's not going to affect your adding, subtracting, square rooting stuff. Anywho, we get 33.7 degrees, I hope. If you did not, double check what mode you're in. and then double check your numbers and whatever you plugged in, okay? Excellent. Now, how do we add vectors that are not perpendicular to each other? That's going to be a little bit more of a challenge. What we got to do is break things down into the X and Y pieces. We're only going to do a little bit of this today. We're not going to finish this up. But this will help us on that handy guide to trig functions if you haven't done it already. So if I walk 3 meters east and then 2 meters at 60 degrees, what's my displacement? You say, oh, that's fine. Let's see. 3 squared plus 2 squared and then take square root, right? Can you do that? No, that's not a right triangle, so you cannot do that. Well, what I would do first is draw out what it looks like, just to see, oh, that's not a right angle, right? So, and then 2, well, it's a little bit, not quite the right size, so we'll stretch that out a bit. Okay? And then my resultant is going to be up like this. Definitely not a right triangle. That doesn't mean I can't make it into a right triangle. You say, what? If I were to take this guy here and break it down into the X piece and the Y piece, then all of a sudden, maybe I do have a right triangle. You say, oh, physics. Yeah. How do I break it down into the X and Y piece? I use trig, sine and cosine. Okay? Remember, and we've already discussed the sine and cosine, but as a reminder, what does sine of theta equal? R over R, y over r. Okay? Well, in this case, I'd be given the r and the theta. What if I want just the y? What would I do to solve for multiply both sides by r, right? So r equals, I'm sorry, I did that wrong. Excuse me. Y equals r times sine theta. I'm going to do the exact same thing with cosine. I'm in space. Cosine of theta equals x over r. But I don't want cosine of theta. I want just plain x. It's going to be x equals r cosine theta. Okay, which is what I've written out down here, and it's also on the board in the room. Okay, if you take a look, it's on the top right. Okay. So, to help me remember all this, sometimes I will put the cosine above the x on my column here, and a sine above the y on my column there. And then what? Then I say 3 cosine 0, enter to my calculator. Tap, 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 please. What do I get? 3. You say, Fair, why did I even have to do that? I knew 3 meters at 0 degrees is just going to be 3 on the x-axis, right? Yeah, but I'm showing you this is always going to work. This way you don't have to remember a whole bunch of different rules. You just say like, oh, this is like my old reliable rule. If I want to get the y component, I'm going to say 3 sine 0. And what's that going to be? 0. Ta-da, right? Okay. Whether you needed it for that one or not, that might help, right? But this one, you're more likely to need it, right? 2 cos 60. Enter. 1. Okay. And then 2 sine 60. Enter. 1.732. Right. Okay. And it says that all up on here, just in case. Okay, so what we just did was break the vectors down into their little bitty pieces. The fancy way of saying pieces is components. You say, well, why would we do that? Well, now I've got all these little x's, and I've got all these little y's. If I add up all the little x's, what am I going to get? Well, yes, okay, I would get, sure. All right, well, let's go ahead and do that. Yes, I get 4, which is my big X. It's going to be on the x-axis, right? If I add up all my little y's, what am I going to get? Okay, I'm up 1.732, and that's on the y-axis. What do you think I'm going to be able to do with that? I'm going to be able to combine those using the Pythagorean theorem. Okay, which is, I just did that right there. So what do we do next? We draw a simple sketch of what it looks like. It doesn't have to be anything to scale, but it should be pretty reasonable. And then you don't have to get out a calculator and a protractor, but make it pretty good. And then I use the Pythagorean theorem. I just put 4.4. But yes, I mean, there was only one significant digit to deal with in the first place, so I'm not being picky. But what about the angle? Quick. Tangent y over x.
Second tangent, y over x.
Degrees. Excellent. Yes, yes. Awesome. Good stuff. Okay, now to review. One last volunteer, please. You get to take our summarizing quiz. Volunteer! Yes, sir. All right, vectors are added. Tip to tail, tail to tail, tip to tip, or poise to men. Tip to all right, excellent. Say next. Oh. To break a vector down into x and y pieces, use the... Go ahead, guys, help them out. You have all the questions on your paper, folks. We're going to run out of time. Quick, quick, quick. Bell rings and we're not done. We're staying. We're done! There we are. Okay, next. Which one is not true? Okay, next. All students take calculus. Now, you may not be familiar with this one. So, I mean, you specifically, but others might be. It's a creepy brainwashing technique to increase higher level math, or adding on the certain angles, or it's a mnemonic device, or all of these. Yeah.
Oh, wow.
50%. Great job. An excellent effort. No, what's really funny is if you still miss, it's always supposed to be very positive. So even if you miss a whole bunch of them, it's like, hey, nice try.